Today's lesson, we're talking about learning target 1, where we're going to start factoring. So here we're going to focus on factoring the GCF, or the greatest common factor, of an algebraic expression. So an algebraic expression is a mathematical statement without a equal sign. So it'd be like 4x minus 2 or x squared plus 3x, those kind of things. So greatest common factor is the greatest number or value that two or more things have in common. We usually call these terms because they're not just maybe just a number or just a variable, a combination of the two. So usually when we're thinking of greatest common factor, we take the greatest common factor out and then we leave whatever is left in the parentheses, so we can kind of call those the leftovers. So here, for numbers, we want to list out all the factors of each number, and then we want to choose the biggest number that they have in common, and then we divide those numbers out of the expression that we were given. For variables, we want to locate the lowest number, lowest exponent of the variable that they have in common. So there may be multiple variables, so looking at common bases and taking out the lowest exponent is what we're looking at. And then we kind of use our division property. So when we divide like bases, we should subtract the exponents to kind of deal with that by factoring out the greatest common factor. So for number 1, we have 4x minus 12. And I want to first kind of look at my two numbers. And I always look at the numbers. Notice that there are, like, the 12 has no x in common with the other one, so we won't probably be able to factor out any x's. But looking at 4 and 12, looking at my factors, it looks like I have a 4 in common between 4 and 12, so I could factor out. So it looks like that is the greatest common factor. So dividing 4 from both 4x and 12 gets me x minus 3. And so then that would be my factored algebraic expression. For number 2, I have 1 and 3. They just have a 1 in common, so we'll be able to factor that out. But that really means they didn't really have anything in common. Here they also have an x in common. The lowest exponent there is 1. Remember that if it's not written, it's assumed to be there. So I really have 1x that I could take out of this expression. So divide both by x. And so because you're dividing by a like base, remember I subtract the exponent, so it's like 2 minus 1 and 1 minus 1. So it leaves me with x to the first plus 3x to the 0. That x to the 0 can go away. So I'm left with x times x plus 3. Okay? And I can continue to do that for number 3. Take out the 2 that 4 and 10 have in common. Squared is the lowest exponent, so I can take out a 2x squared. So I want to divide both of those terms by 2x squared. And that's going to leave me with 2x squared times 2x plus 5. Okay. Now sometimes you may have more than 2 terms, so here I have 3 terms. So I want to look at all 3 of those numbers and look at the factors that they have in common. So it looks like they have a 3 for a number in front, so I can take that out. And then for the lowest exponent of the x's that they have, it's just x to the first. So I want to divide each of these terms by 3x. And so then the first one will be 4, but then to the 5th minus 1 will get me 4, so it's 4x to the 4th. The second one is 3 minus 1, so it'll be x squared, so minus 6x squared. Notice that the negative still stays there. And then 3x divided by 3x actually cancels each other out, so it's not going to be 0. This is a common mistake. It should be 1 there. So that'll be my final answer for that one. Number 5. Now here I want to kind of show you a different way of kind of writing these out. You can actually list out all the factors and then all your variables as well, like in singleton kind of mode, and then you can use those to kind of circle the ones that they have in common. So here I listed all those out. They have a 2 in common. It looks like they have 2 x's in common, and they have 2 y's in common. So I could factor out 2x squared, y squared. And so then from there I can use the same division to take that out. So then that leaves me with 77x, because that's the only variable left, and then plus 5y squared, because that's the only y and number that are left. Okay, so then that would be my answer. Number 6 has 3 terms. Now I can do the same thing. I can list them all out. Now sometimes if you want to do this, it could be kind of tedious because notice that I have a lot of variables, so it's a lot of writing. But it is visually like a little easier to kind of tell what you can and what you can't take out. Okay, so now I see that they all have a 2 in common. It looks like they have 3 x's in common, so it's x cubed. And then it looks like they have 4 y's in common. So I have y to the 4th. So I can write that out here in front of my parentheses first, and then looking at the first term, I have an 11, x squared, and then 3 y's in common. And also, I can kind of just count them. So that's how I kind of add them up. I don't have to worry about division. So I can do that with all the terms to get that final answer. Okay? Have fun.